And let me introduce myself first. My name is Cheng-Hsun, or you can call me Jim. And I'm currently studying in National Yangming University in Taiwan. I major in medicine. And this is the outline for today's presentation. I'll start with what is the project about, and then how to approach the project. And third, I'll talk about things to be solved and the timeline for the project. So let's start with what is the project about. This project is about to turn the mathematical models of contextual geometric structures into computable platform. And what is CGS? It is a model that is able to simulate the interactions and evolutions of cultures through mathematical models. And what is special about the model is that it is a physical, it is a hydrodynamic model, and it consists of kernels and environmental flows. I'll talk about the kernels and environmental flows later. And this model includes a lot of stochastic process. And so the stochastic process gives the model the advantages to mimic the complexity of cultural interactions. What I mean is that this model is not deterministic, rather it is stochastic, and I think it is the right way to simulate how culture interacts. So let's talk about kernels first. Kernels represent a person's concepts toward a specific thing. So for example, let's take the two-dimensional kernel here. And in this two-dimensional kernel, it is used to depict the concept of temperature within different culture. So for culture A, you can see that for culture A, the threshold for hot is higher than the threshold for hot in culture C. So there is some difference between cultures. And cultures are not only two-dimensional. You can set kernels to different dimensions. For example, you can set kernels to two-dimensional or four-dimensional. And the values of the kernels represent a person's or a culture's evaluation toward a specific concept. For example, toward the concept of temperature, or to the concept of favor. Okay, and the other important idea about CGS is environmental flows. Environmental flows represent the environmental forces that influence interactions of different cultures. So it is like when different cultures meet together, there may be forces that pull different cultures together or pull those cultures apart. So in environmental flow, all kernels cluster together initially, and they will be diffused by the environmental flows. So the environmental flows may result in segregation or aggregation of different kernels. And finally, the kernels will form different structures. For example, you can see that there may be a homogeneous vortex in this area, and heterogeneous edge cluster in different places. So finally, we can try to interpret these structures as the evolutionary result of cultures. And a special measurement called iterated temporal divergence can be used to measure the divergence of kernels within the flow field. And it can be used to measure how how well different kernels, different cultures become the same or become different. Okay. And this GIF image is what I plan to finish for the project. And you can see there are two kinds of polygons in this graph. And the polygons represent the kernels. So you can see that the kernels are moved by invisible flow field, and finally they may be clustered together or separated apart. And there is a tendency that similar kernels cluster together finally. Okay, this is the idea of CGS, and then I'll talk about how I want to approach the project. And in my opinion, the most important part of the project is the simulation of environmental flow field. So I start with looking for a suitable tool to simulate the flow field, and I found parcels. Parcels is an open source tool for simulating the ocean flow field, but it is still manageable to turn it to simulate the CGS module if I do some modification. So in this project, I will work with Python, Jupyter Notebook, and SciPy. And I'll talk about how parcels build environmental flows. So to set up environmental flows, I'll have to define the field steps first, and we can take a look. Okay. This is the documentation of the parcels, and you can see that it is easy to define the field steps if you provide the zonal velocity and the meridional velocity to the field step. And if you provide these two velocities, you are able to define your personal field set for parcels. So I will start with defining my intended field set. Then and also parcels provide the function to plot the moving track of particles in the field. And like you can see from this animation that these particles are moved by the invisible flow field, and you can imagine that these particles can be somewhat turned into kernels for CGS use, and so this animation will be like my intended CGS model. And so after setting up the environmental flows, I'll define kernels for CGS use. So I'll have to define the particles. And it is also easy to create particles in parcels. And but in parcels you can only define these 5 parameters. And if I want to turn the particles into the kernels for CGS, I'll have to add an additional attribute, which is the n-dimensional tuple, like this n-dimensional tuple. So after doing these two things, the basic code base for CGS can be completed. And in practical, in my practical code, I don't want the CGS users to directly implement parcels, because if they want to use parcels, they'll have to read the documentation of parcels. But I want them to use the CGS by the APIs I provide. So I'll try to wrap up parcels in my code. And also, after finish the code base, I'll try to create Jupyter notebooks for tutorials and also for user-friendly interfaces. Then let's talk about things to be solved. And I have discussed these things with my mentor previously, but we think that these things should be discussed before before real coding starts. So I try to think about these things more. And some things need to be solved is that how kernels interact with the environmental flow or other kernels. You can imagine that individuals with similar cultural background may tend to get together, and likewise, similar kernels may cluster eventually. And if I want similar kernels to cluster eventually, it means that I'll have to think about the attributes of kernels that may bring similar kernels to cluster together and repel different kernels if they don't look similar. Also, another thing need to be solved is that how to set the values of the kernels. For example, we can take a look at this polygon, and if I want to set the values of different axes, maybe I'll have to project this red dot onto this axis and onto different axes, but I don't think that it is really required to project the red dot onto different axes. It may be also possible to just set up the values of the kernels of the tuples that these different values are independent. So this is the detail of the project, and I'll discuss with my mentor further later. And also, I have to think about to what extent can CGS users modify the code for their own purpose. There may be some parameters that CGS users can modify for their own purpose, and how many parameters can we really change? That is the thing I need to think about. So finally, let's talk about the timeline for the project. For GSoC, there are 3 coding periods. For coding period 1, I plan to create code phase for simulation and also add tests to avoid code crashing. And for coding period 2, I want to set up biodiversity benchmark to evaluate the performance of the project. But I haven't discussed with my mentor about the benchmarks. benchmark yet. And I think that the benchmark setting should be depending on how I really create the code base for simulation. So maybe I'll discuss with my mentor about it, about a benchmark after coding period 1. And finally, in coding period 3, I'll try to document the entire project. And also, coding period 3 serves as the buffer period. If I have something that haven't been done yet, I'll try to make up during this time. Okay, that's all. Thank you for listening.
Thank you very much. That was very good. So I was writing notes while you were presenting, and I got a lot of things to think about, like in terms of, we'll talk about this throughout the summer.
Yes.
So, like every week, on Slack and so forth, we'll kind of discuss these issues. So, yeah, it's going to be, pretty fun. I think it's also going to be pretty sort of fluid and seat of the pants somewhat, because, we'll see what works,
Yes.
So if we run into any problems, we'll try to overcome them as we go. But I think this is a good start. I think you've thought about this. So we'll just kind of go through throughout the summer. And then now these slides that you've just presented you're going to do a final presentation, which is going to be, like what came out of the project. So you'll build off of these slides for that last presentation, and you'll just say, okay, what did we learn from this project? What did we accomplish?